Okay, now I have the data, and now I'm ready to run the analysis. First of all, the correlation, if I want, I would just simply use core-rel function, and then arrange 1 is this, arrange 2 is that one. Maybe I didn't. And arrange 2 is this. So I know the relationship is 0.759. So there's a positive linear relationship between calls and sales that I know, and how strong the relationship is. And I want to analyze that by using linear regression. And if you go to linear regression, I can analyze it by using data. Let's see.
So 0.759 is the correlation of a coefficient of correlation, right?
Yes. That. Okay. Oh no, coefficient correlation is, this is R.
Okay, R, yeah.
Okay, this is R. Right?
Yep.
And R square. Right? R square is going to be simply this one times that, right? So the coefficient of correlation is 0.576. That's R square.
And what does that mean? I get the correlation. What does that number mean? The 0.5.
Yeah, that means, how much does this explain the sales, right? So so right now sales is determined by number of calls. That's what we hypothesized, right? In other words, the more calls you make, the more sales you're gonna make, and how much of that is explaining sales itself. What kind of explanation power does it have? That is going to be explained by this simple equation: y equals x, and y is sales, and x is calls, right? And we are saying that 57.6%, right? So 57.6% of sales is explained by the number of calls you are making.
And what type of number would you feel is 57%, like more than half, a good thing to say that has a strong explanation of it, or would you look for another explanation after that?
That's a very good question. In social science, if it is greater than 30%, it's very good explanation power, because there are a number of factors go into sales, right? So if you have more than 30% of explanation power, that's pretty good. That's considered pretty good.
Oh, okay, cool.
Yeah. So incredibly, it says 57.6%. It's just a fictitious case. That's why this is high explanation power.
Yeah, I think this is definitely maybe a use case that it should be, but probably because if you're not calling people, you're not selling things, right? I guess.
Yeah. Yeah.
So I guess that would make sense to pass a smell test a little bit, I guess.
Yep. So now, if you were to calculate the slope of the linear regression, then you are going to now go with the data analysis. Under data, you have data analysis. If you are using Excel or Mac, it should be the same. So under data analysis, I'm going to go there, and there are a few things that you can choose. I'm going to choose regression. Click OK, and then input Y range. Right, Y range is sales, so I'm gonna include the sales over there, and then X range is number of calls, right? And then I say labels are included, so I'm gonna check on labels, and I'm going to have the result on a new worksheet. So that's good. Right now, I'm not concerned about this, so I'm not going to cover this. So click on OK. Then now I have the Excel
Jeez.
result.
That's awesome. As all the things. Yeah.
And I'm interested in this R square. And correlation is also given here. And this and p-value and coefficients. So first of all, I understand that R square is 0.576. So again, 57.6% of the variance of sales is explained by number of calls that you are making, which is really high. So we see that calls are very important in sales in this case. And I'm going to write out the formula. So the regression line equals sales equals intercept is 18.947 plus 1.184 times calls. Right. So that's the regression line that you find here. Do you understand, team?
So what it's saying is that for every call, we multiply it by about 20, and that's the sales that we get, or no.
1.184. That's a multiplier here.
Okay.
But,
okay.
Yeah, intercept is the intercept. It does not affect the number of calls.
Okay.
Isn't this equation used to create a prediction for given any number of calls, what the projected sales would be?
Yes, you are correct.
Yeah.
So 1.184 is the impact that one sales call makes on sales. For example, if you make one call, then
it creates more than one sale.
Yeah, it creates 1.184 sales, right? So now when you are making 30 calls, how much sales, right? So we can now make the prediction here, and sales is going to be equals 18.947 plus 1.184 times 30 calls. Then 54.467 is going to be estimated sales that you're going to make for this case. So approximately 55 or 54, right?
Wow. Yeah.
However, you have to take a look at this p-value is quite important. P-value says that whether this is a trustworthy variable or not. And by the rule of statistics, if it's less than 0.05, then we say these coefficients are trustworthy, right? Given the sample size. So I see that both of them, especially calls here, is the p-value is 0.01. Therefore, I can confidently say, given the statistics, that 1.18 is trustworthy coefficient, right? You can trust that 1.184 has statistical power to explain the variance of sales. So this prediction is, something that you can confidently rely on.
Oh, okay, cool.
Right. However, sometimes say it's say 0.15, right? You have p-value of 0.15.
That's 85%, right?
Then there's no reason for you to trust this coefficient 1.18. You should not rely on this number because it does not do anything. Or the R square, say it's 0.10. It's only 10% of explanation power. So I wouldn't even bother looking at this coefficient.
Okay.
Does it make sense to you?
Yeah.
Okay.
What is just for like the theory side, what would be the p-value that changes? It's 5. It's like, that's 0.056. So that's close enough, right? Like you would say that's 95% confident. Is that what you're saying?
Yeah. So 95% of confidence we have. And I would say, intercept is not as important as the factor that we are looking at. We are looking at this number of calls. That's the interest that we have in, right? So we want to know the number of calls that you are making is impactful for your sales owner. That's what we are looking at.
Yeah.
And the intercept is something that you don't have to pay much attention to in linear regression. Right now, it's just a simple linear regression, but we can expand it to multiple linear regression where we include number of calls and the kind of the products that you are selling, the incentives or discounts that you are giving to the customers, the number of ads and number of emails that you sent, right? Or the longevity of the relationship with the customer, or the customer's financial capability, right? All kinds of things are going to go into this sales prediction. At the time, we have to run linear, not simple linear regression, but multiple linear regression. And in that case, intercept does not mean anything. Just need to look at the coefficient of factors.